Hello everyone, this is Amulya. Today I want to share the information about the bus structure in a computer organization and architecture. Introduction. A bus is a communication pathway connecting two or more devices. A key characteristic of a bus is that it is a shared transmission medium. Multiple devices connect to the bus and a signal transmitted by any one device is available for reception by all other devices attached to the bus. If two devices transmit during the same time period, the signals will overlap and become garbled. Thus, only one device at a time can successfully transmit. Here we move on to the bus structure in computer architecture. The bus structures in computer plays important role in connecting the internal components of the computer. The bus in the computer is the shared transmission medium. This means multiple components or devices use the same bus structure to transmit the information signals to each other. At a time, only one pair of devices can use this bus to communicate with each other successfully. If multiple devices transmit the information signal over the bus at the same time, the signals overlap each other and get jumbled. A system bus has typically from 50 to hundreds of distinct lines where each line is meant for a certain function. These lines can be categorized into three functional groups, that is data lines, address lines and control lines. Let us discuss them each one by one. This is the structure of the bus in a computer. It consists of three sets of lines which is used to carry the address, controls and data. First we discuss about the data lines. 1 minute. Data lines coordinate in transferring the data among the system components. The data lines are collectively called data bus. A data bus may have 32 lines, 64 lines and 120 lines or even more lines. That is 2 power n, which is more than the number n is more than 5. The number of lines present in the data bus defines the width of the data bus. Each data line is able to transfer only one bit at a time. So the number of data lines in a data bus determines how many bits it can transfer at a time. The performance of the system also depends on the width of the data bus. Let us move on to the address lines. Address lines of the bus determines the source or destination of the data present on the data bus. The number of address lines together is referred as the address bus. The number of address lines in the address bus determines its width. The width of the address bus determines the memory capacity of the system. The content of address lines is also used for addressing input-output ports. The higher order bits determine the bus module and the lower order bits determine the address of memory locations, or also known as the input-output ports. Whenever the processor has to read a word from memory, it simply places the address of the corresponding word to the address line. Control lines. Here address lines and data lines are shared by all the components of the system, so there must be some means to control the use and access of data and address lines. The control signals placed on the control lines control the use and access to the address and data lines of the bus. The control signal consists of the command and timing information. Here the command in the control signal specifies the operation that has to be performed and the timing information over the control signal specifies when the data and address information is valid. Let us discuss about the control lines. Include the lines for memory write, memory read, input output write, input output read and transfer ACK, that is the transfer acknowledge. Memory write the command which causes the data on the data bus to be placed over the addressed memory location. Similarly, memory read the command causes the data on the addressed memory location to the placed on data bus. Input output write is the command used over this control line causes the data on the data bus to be placed over the addressed input output port. Input output read is the command used over this control lines causes the data from the addressed input port and output port to be placed over the data bus. Transfer acknowledge it is used to control line indicates the data has been received from the data bus or is placed over the data bus, which the control lines indicates the data has been received from the data bus. Bus request. This control line indicates that the component has requested control over the bus. Bus grant. This control line indicates that the bus has been granted to the requesting component. Interrupt request used to control line indicates that interrupts are pending. Interrupt acknowledge or interrupt ACK. This control line acknowledges when the pending interrupt is serviced. Clock. Clock controls line used to synchronize the operations. Reset. Reset is the bit information over this control line initializes all the modules. Timing in bus. As we have seen, the bus's control lines also provide timing information along with command. Well, the way of deriving the timing information over the control line can be categorized into two ways, that is synchronous bus and asynchronous bus. Let us first discuss about synchronous bus. With a synchronous bus scheme, all the devices or components connected to the bus derive timing information over the control line referred to as the bus clock. Over the bus clock line, the clock transmits an alternating sequence of 1 second and 0 second at regular intervals. A single 1 to 0 transmission is considered a clock or bus cycle, that is on or off. 1 and 0 indicates on or off. Asynchronous bus. The clock does not synchronize the transmitter and receiver components in this synchronous bus scheme. Instead, the data transfer is controlled using a handshake protocol between the master component and the slave component. This is the bus structure for input-output interface of an input device. Let us discuss the structure one by one. Each input-output device interface has a set of registers with unique addresses. Whenever the processor puts an address over the address line of the bus, it is examined by all the devices connected to the bus. Whichever device recognizes this address responds to the control operations issued on the control lines of the bus. The processor issues read or write operation over the control lines of that bus, and data corresponding to the read and write operation is transmitted over the data lines of the bus. Here, this is the example for the instructions in a bus. Load R2, data in. Here the data in is the data register of the keyboard. This instruction reads the contents from the data in register of the keyboard and transfers the content to the R2. Similarly, the instruction below. Store R2, data out. This is the information about the bus structure in computer organization and architecture. Thank you.